Using the player. Toggle the menu button to see where you are in the training and to jump to any specific section. Toggle the Notes button to see the notes for each slide. Use the magnifying glass to search for specific text within the unit. Toggle the hamburger to display slides full screen and to reveal or hide the menu and notes. The Resources button in the top left contains helpful links to documentation and websites. Control the player volume at the bottom of your screen next to the Play button. Continuing along the bottom of your screen, you can also reload a slide and move to previous and next slides using the buttons in the lower right-hand corner. Before you begin this course, ensure you have a solid understanding of plain JavaScript and basic knowledge of AMD, HVVM patterns, HTML, CSS, and XML. This course is organized into units containing sections and lessons. This course introduces developers to the Magento 2 JavaScript platform and associated development techniques. It is intended for developers who want to develop essential skills in implementing and customizing solutions using Magento 2 JavaScript-related functionality. The course begins with a discussion of the main technology stack. Students learn essential components of JavaScript architecture and are guided through the Magento modular structure, types of JS modules execution flow, customizing JS modules, core JS library, Mage widgets, customer data framework, and Magento UI components. UI components are known to be challenging, so they are covered in depth in this course. The course presents UI components concepts and problems this framework aims to resolve. Students are guided through the different stages of a UI component lifecycle and obtain a deep understanding of its workflow and areas of application. Specific examples of UI components, such as grids and forms, are also covered. JavaScript in Magento 2. This course was developed using Magento 2.2 software. Unit 1. Technology Stack. This unit provides an overview of require.js, _JS, jQuery and jQuery widgets, and knockout.js. In this section, we will go through an overview of require.js and cover the require.js config file and require.js plugins. This lesson is an overview of require.js. Refer to the official website. It has a lot of information about require.js, how to use it, and some advanced features. You may also want to explore the require.js source, which you can find on the GitHub link provided on the slide. The GitHub has some additional information. When a require.js library is a pretty simple technology based on the AMD approach, you can learn more about the AMD specification on the official require.js and GitHub sites. The require.js library has two main principles. It splits the JavaScript code into logical parts called modules for further use. Later, we will look at the exact syntax for writing and executing an AMD module. It is important that a module's dependencies is a part of the module definition. When a module is called, require.js loads and instantiates its dependencies first in a non-blocking, asynchronous manner. AMD module created by the special define function. Magento has a convention that each module must be placed in one file, so each JS file represents one module and contains a call to the define function. The define function takes three parameters: module underscore name, dependencies array, and factory function. Module underscore name and or dependencies parameters can be omitted. Factory function is a function that takes each dependency as a parameter. Inside a factory function, you can run any initialization commands. Whatever function returns is recognized as a module. The define function executes only once per module. It is technically possible with require.js to execute it multiple times, but it is not used in Magento and is out of scope for this course. Some examples on how a module can be defined are detailed in your notes. They include value pairs, no module name, no dependencies, no init logic. As a function, no module name and no dependencies, but some init logic. As a function with the dependencies but without a name. This is the most common use in Magento. Note, The return value from the factory function could be whatever. It can be an object, it can be a function, or anything else. We call exports the result of factory function execution. There are multiple ways to refer to a module name. The simplest one is just a path to the module's JS file without JS extension. It is possible to define the base URL parameter, which defines a root folder for JS modules. We explore doing that later in this course. It is also possible to define aliases for modules, which we will see in the next section. For more details, refer to the official documentation. See the example in your notes. This is a simple example of the require.js execution process. As you can see, we've defined jQuery and our custom module and put a variable from custom module into the body section. It's a pretty simple example, but it shows the essence of what is happening and how the execution flows. Let's look into an example. Assume we have three modules, Module 1, Module 2, and Module 3. We're calling the require function with dependencies for Module 1 and Module 2. At the same time, Module 1 has another dependency for Module 3, and Module 2 has no dependencies for Module 3. Let's see what happens when we call require on the next slide. When we call require, it generates two script tags for Module 1 and Module 2 and inserts them into the page's body. It preserves callback 1 for later use by putting it in the registry. This is simplified schema. In reality, it wraps the callback and dependencies with an anonymous RJ module. When the scripts are loaded, in any order, the define function is executed, but not factory function. Define for Module 1 places dependency, Module 3, and factory 1 in the queue, and later by another function working on timeout, which is not shown in the diagram, generates a script tag for Module 3 and places factory 1 in the registry. At the same time, after Module 2 is loaded, its factory 2 function is also placed in the registry, but not executed immediately. Let's continue on the next slide. Some functions on timeout will execute the factory 3 function, which will trigger a notification for Module 1 that Module 3 is ready. Since Module 1 doesn't have any unresolved dependencies, its factory 1 will be executed and its result will be stored as exports 1. After that, Module 1 will trigger a notification to callback 1 that Module 1 is ready and exports 1, the first parameter, is also ready. However, callback 1 has another unresolved dependency, so it will continue to wait. Another timeout function, or even the same one, will execute factory 2 and generate the exports 2 object. After that, Module 2 will trigger a notification to callback 1 that it is fully loaded and the exports 2 parameter is ready for callback 1 to consume. Since callback 1 doesn't have any unresolved parameters now, and both requested parameters, exports 1 and exports 2, are ready, callback 1 will be executed with the parameters m1 equals exports 1 and m2 equals exports 2. Require.js does not guarantee the order of loading modules. The exact flow may be different from the one we described. We don't know if factory 2 or factory 3 will be executed first. Require.js does guarantee the order of dependencies being executed. This means factory 3 will always be executed before factory 1, and both factory 1 and factory 2 will always be executed before callback 1. All processes inside Require.js happen asynchronously in a non-blocking way. Follow the instructions on the slide to complete this exercise. This lesson covers the Require.js config file. Require.js has a variety of configuration options. These options allow you to define different things. Paths. Define an alias to a certain path. For example, foo can be an alias on the path js/scripts/v1. Module aliases. Set a short name for a module rather than calling its full path to the JS file. Parameters mapping. Identifies the exact module to meet a dependency specified in the define function. Global dependencies. Load certain modules before any other. Base URL. Specifies a root folder for JS modules. External libraries. Can be added to the project using a ship configuration option. Refer to the official documentation for a full description of all available config options. At the top of almost every Magento page, there is a snippet of inline JavaScript. This defines a base URL for require.js. It is important that this declaration is pasted above the require.js script tag. Base URL means that require.js will consider every path relative to base URL. So if we call require test/module1 m1 equals true, require.js will be looking to the file magento URL/pub/static/version 15146593977/frontend/magento/luma/en_us/test/module1.js. In Magento, configuration options are placed inside the require.js-config.js file. It is generated by a special procedure that we will cover later in this course. In general, require.js configuration is passed through the config method of the global require object. A parameter of that config method is an object with properties. Using the map property, you can define an alias for the module. While it is optional and does not have any impact on functionality, aliases can be useful in development. So instead of define script/subfolder/module1 function m1, you could write define module1 function m1, assuming the config declaration from the slide is in place. The map configuration option is a little deeper than aliasing, but in Magento you would find a lot of code like what is shown on the slide. The map configuration option lets you define the exact module that will be used in the dependency for another module. In other words, let's assume that we have the following code. Module2.js define module1 factory2, module3.js define module1 factory3. The map property lets you set different values for module 1 in the two declarations that we just mentioned. This map is displayed on your screen. With such a configuration, module 2 and module 3 will receive two different instances as their module 1 parameter. Refer to the documentation for more details. You can declare global dependency using the deps config option. Using this option is equal to the call require deps function, which will do nothing but load dependencies. Shim config options let you wrap an external library to the require module format. Follow the instructions on the slide to complete this exercise. This lesson covers require.js plugins. Plugins are special modules that implement certain interfaces. Plugins are initiated before any other dependency. Plugins are specified in the definition in the following format. On the slide, we can see an example of the plugin declaration in the define function. The plugin should be marked with an exclamation point symbol at the end of its name. Everything after exclamation point is treated as a plugin argument. The slide shows a text plugin which allows you to load a file from the server as plain text. Because require.js does not guarantee the exact order of loading modules, we cannot be sure that the modules are executed after DOM is loaded. This means that the modules are dependent on the DOM structure. We have to take extra steps to ensure the DOM structure exists by the time the modules load. The DOM Ready plugin achieves this goal. By adding DOM Ready exclamation point to the list of dependencies, we artificially delay the define execute until DOM is loaded. Follow the instructions on the slide to complete this exercise. In this section, we will go through the underscore utility functions and underscore templates. This lesson covers underscore utility functions. Underscore.js is a small but powerful library that contains many utility functions that simplify JavaScript development. Underscore provides ES6 type functions compatible with most browsers. Magento actively uses underscore in its core modules. The most important underscore features used in Magento are the extend function and templates. On the slide, we have an incomplete list of underscore collection utilities functions. Refer to the documentation to see the full list. Usually, underscore is exported as the underscore symbol, so in order to call a function, you would use underscore some function parentheses args. This is an array utilities function. The example uses ifFlatten function, which will return a plain array out of multidimensional. In the example on the slide, the result is bracket 1, 2, 3, 4, 5, 6. This slide shows some of the function utilities. The example shows the defer function. It is used in Magento and is an analog of setTimeout function 0, which is a very useful technique to write non-blocking code leveraging event loops. The slide shows some of the object functions provided by _JS. The extend utility function is one of the most used in Magento. It allows you to extend an existing object with a given one. It is important to understand the details of exactly what it does. One of the exercises at the end of this section will ask you to do exactly that. Follow the instructions on the slide to complete this exercise. This lesson covers _templates. Underscore templates are very simple string-based templates. Template rendering in the underscore library happens in two stages: template compilation using _.template function, template rendering by calling the result of _.template function, which is another function, with the data argument. Underscore templates are very powerful and simple. However, they are not very extendable, and the syntax does not encourage you to write complex user interfaces. Magento uses underscore templates a lot, though it does have another template rendering engine that we will describe later. The slide shows a syntax for underscore templates. There are three key syntax elements. Equals some value will output a some value. Dash some value will HTML escape and output some value, which is useful for displaying special characters like carets and prevents XSS attacks. ... executes an arbitrary JavaScript code. The slide shows an example of rendering the underscore template. The template itself is a string. It's called out in your notes, and it's on screen on your slide. As you can see, even a simple template doesn't look very clear when we use a little bit of JavaScript code inside. This slide continues the previous example and shows how we use a template in our require.js modules. Assume we have the same template as on the previous slide somewhere in the HTML file. The module on the slide will load it using the text plugin and compile. The module provides default values for the template. However, it allows an end user to customize the data by returning a function that takes data as a parameter. Properties from the data parameter will override the default one. We continue the previous example. This slide shows how to execute the module we've defined on the previous slide. We require the module and receive module instance, which is the function taking one parameter. The parameter is an object that contains one field, name, Captain Jack. This will locally override default values coming from the closure and render the text with a new name. Next time we call this function, it will use the same default parameters. Follow the instructions on the slide to complete this exercise. In this section, we will go through an overview of jQuery and discuss jQuery widgets. This lesson is an overview of jQuery. jQuery is probably the most popular JavaScript library in the world. In this section, we won't cover it in full detail. We will cover the key features that are used in Magento intensively. This slide shows the most typical uses of this jQuery function. It may be used as a wrapper for DOM elements, which provides many utility functions and simplifies event handling. jQuery also provides a framework for AJAX calls. And finally, very importantly, deferred. Deferred is used very often in Magento. This is an analog of ES6 promises, though not fully functional. Magento extends the jQuery prototype with a series of functions which we will cover later. For now, note that jQuery uses the symbol $.fn to represent its prototype. The jQuery library is equipped with a huge number of different plugins such as calendars, toggle switchers, tabs, modal windows, and many more. Magento uses some of them and adds its own jQuery widgets. The jQuery library is separate from jQuery core. It provides a large set of plugins, widgets, and different utility functions to build UI elements. Refer to the official documentation for more information. jQuery can be easily used with require.js. It exports itself as an AMD module. However, not every jQuery plugin does the same thing, so sometimes we would use the shim config option to add a jQuery plugin. Follow the instructions on the slide to complete this exercise. This lesson covers jQuery widgets. jQuery Widget Factory is an extensible base through which you can create and extend your own widgets or use default widgets. Using the Widget Factory enables you to conveniently manipulate with the state, give conventions for common tasks like exposing plugin methods, change options after instantiation, create object-oriented components without reinventing common infrastructure. The Widget Factory is a function of the global jQuery object, jQuery.widget, and accepts 2 or 3 arguments. $.widget (plugin name, parent, implementation). Plugin name is a string format containing namespace, and plugin name is separated by a dot. Namespace.pluginname, where namespace is required and it refers to the location of the global jQuery object where the widget prototype will be stored. If the namespace does not exist, the Widget Factory will create it for you. Plugin name is the actual name of the widget. Parent, optional argument through which you can specify one other widget. Implementation, plugin implementation specified by js-object, and the last one becomes a prototype for the plugin's instances. Note, in this course we will consider mostly Magento relative approaches. Refer to the official jQuery and jQuery widget documentation if you would like additional guidance on this topic. Once you make the call to a jQuery.widget, there will be a new method available in the jQuery prototype. The .fn method works as an interface between DOM elements contained in a jQuery object and instances of the widget prototype. The relationship between the prototype and jQuery.fn is implemented through jQuery.widget.bridge. Also, a pseudo-selector will be generated for querying and filtering based on the namespace and name. This is an example of a minimal jQuery widget. jQuery widgets can be extended by passing an object to extend as a second parameter to the jQuery Widget Factory as shown on the slide. All jQuery widgets have a very important feature, inheritance. This allows us to make plugins based on other existing plugins. To do this, we set an example with the parent plugin like the second parameter of the $.widget method shown in the example on the slide. Widget methods are available through jQuery prototype methods or through an instance. Let's take a closer look at how it works on a simple application with the structure shown on your screen. As you can see, it's pretty easy to connect jQuery.js to your application. We also connect jQuery-UI.js script and jq-custom.js. Let's take a closer look at the last file. Reload the page and check the results. Now it looks the same as the parent dialog widget, but with one big difference. You can extend it. Note, if your plugin is based on another plugin, that means your plugin will have all the parent options, which you can change if needed. Later in this chapter, we will do an exercise with jQuery widget and _JS. jQuery widget code for exercise. Follow the instructions on the slide to complete this exercise. In this section, we will discuss Knockout.js, key features, templates, and Knockout ES5. This lesson covers Knockout.js key features. Knockout.js is a JavaScript library implementation of the Model View View Model, or MVVM, pattern with templates. JavaScript out of the box doesn't have a mechanism of binding properties of DOM elements to fields of viewModel and PubSub infrastructure to support elements related to the changing values of the viewModel fields, but Knockout.js solves these two main problems. The main principles of the Knockout.js library are a clear separation between domain data, view components, and displayed data, A clearly defined layer of specialized code to manage the relationships between view components. A clearly defined layer of specialized code to manage the relationships between the view components. The main core features of Knockout.js are observables, declarative bindings, and templating. Note that in this course we will consider mostly Magento relative approaches. Refer to the official documentation for additional guidance on this topic. This slide demonstrates how MVVM works, where View, interactive UI representing the state of the view model and updates information and sends commands to the view model, View Model, a code representation of the data and operations on a UI, and Model, application stored data and represents objects and operations in your business domain. Knockout's declarative binding system provides a way to link data to the UI. The Knockout.js framework does a parsing of the dataBind attribute and executes JavaScript expressions. The dataBind attribute consists of two items, binding name and binding value, and is divided by a colon, as shown in your notes. It can also be separated by a comma, also shown in your notes. Activating. To activate Knockout, add the following line to your script. ko.apply_bindings (myViewModel) in parentheses semicolon. Apply bindings can take two parameters. The first parameter takes your ViewModel object with the declarative bindings it activates. An optional parameter can define which part of the document you want to search for dataBind attributes. It's pretty similar to the JSON-object and gives us the ability to connect the data and the events-handler in the DOM node. See the link in your notes for more information. After looking at the basic view model, let's consider the key benefits of the KO framework, namely observables. On the next few slides, we will consider ko.observable and ko.observableArray. We will take our existing view model and extend it with ko.observable, and then we will see how the UI will update automatically when the view model changes. Refer to your notes for the specific strings of code. Begin with this.customerName equals ko.observable SAM. Add a new binding to customer name to our section, and create a new section with a simple form. Now when we reload the page, we will see a new field, customer name with SAM as a default value, and a form with an input field titled customer-name. Change the field in your form, and you will see how the name is changed for text data-bind binding. KO Observable is a special JavaScript object that can notify subscribers about changes and automatically detect dependencies. Because of this, KO knows what parts of ViewModel have been changed. Also, you can make your own subscription to observables, but this feature is for advanced users only. To find out more information, see the link in your notes. Knockout.js has one nuance for input field changes that happen via JavaScript events on Blur. If you want the changes to happen instantly, you need to make your own wrapper for it. What if you need to dynamically change an array? As we have already found out, we're using observables when we want to detect and respond to changes on some object. But if we want to do the same thing with collections, we should use an observable array. Some ways to manipulate with arrays are push, pop, unshift, shift, reverse, sort, splice. All these functions are equivalent to the native JS functions and then notifying listeners about changes. For more details about these functions, see the link in your notes. Some useful functions that KO adds on its own are replace, remove, destroy, and so on. For more information about observables, see the other link in your notes. One more important thing, ko.dependentObservable parentheses. In other words, you can define an option in ViewModel, which will depend on the other options, and KO will do automatic dependency tracking, which is nice. See the next slide for a code example. Observable Array Example. One more powerful technique in Knockout.js, all KO bindings that control flow can be applied like virtual DOM elements defined by a special syntax. KO binding control flow variable. For more information, visit the link on your screen. On your screen is an example of Knockout with Require.js. Follow the instructions on the slide to complete this exercise. This lesson covers Knockout.js templates. Template binding populates the associated DOM element with the results of rendering a template. Template binding defines the data container for the template, and usually is some part of a view model. The native Knockout template engine used inline script tags with some special syntax as a container for a template. Magento defined its own custom Knockout template engine, which allows you to load templates from special HTML files. In the example on the slide, we can see how Knockout templates look. The template itself is placed inside a script tag. The view model provides data that can be connected to the template using template binding. Template binding is applied to some container node, and the same template may be used multiple times. It is also possible to render a template multiple times using a for each statement in the template binding, as shown on the slide. Templates can be rendered without a container node using Knockout containerless syntax. Follow the instructions on the slide to complete this exercise. This lesson discusses Knockout ES5. The Knockout-ES5 purpose is to simplify Knockout observable syntax and leverage ES5 getters and setters. The Knockout-ES5 extension extends a KO object with a method, track, that makes all properties observable. This simplifies the use of Knockout inside other systems. See more details at the documentation page linked on your screen. Regular Knockout doesn't use ES5 getters and setters in order to support older browsers. This can be confusing. Is the value we deal with a function or an object? Knockout-ES5 adds the use of getters setters, which allows you to consistently consider view models' properties as regular values. Follow the instructions on the slide to complete this exercise. Congratulations! You have completed this unit.